Yeah, good morning, students. It's my pleasure to introduce this today's classroom discussion topic, that is on dynamic memory allocation functions. So, in the previous classroom, we had a discussion on the sparse matrix and its representation using arrays as well as linked list representation. Fine. So now I would like to share my screen. So hope my screen is visible. So the topic for discussion is memory allocation functions. Fine. So here the summary of the previous unit is that the sparse matrix can be used instead of a simple matrix. So because of this storage and computation time saving, we are making use of this sparse matrix, and we are representing the sparse matrix using arrays and linked lists. So the memory allocation functions, the lecture objective is that this session will develop the students' knowledge on MLOC, CLOC, RealLoc, and free functions, which are used for dynamically allocating the memory. So the outcome of this today's session is that after completion of this session, students will be able to make use of this dynamic memory allocation functions in implementing the different programs related to these arrays and its operations. So dynamic memory allocation. So in C language, the exact size of an array is not known until the compilation time. So that is the reason while we are declaring the array itself, we are ensuring that the maximum size of the array we are declaring that. Suppose integer array A is of some size, you are declaring it as A of some 50, you are declaring that. So maximum we are ensuring that the n value must not be greater than 50. So that is the reason the memory allocated for this arrays are at compilation time we are allocating this memory for this arrays. So if we want the memory to be allocated for this array based on this n value which we are inputting, that is the number of elements, total number of elements in the array. So based on this n, you want to allocate the memory for this array variable A. So how do we do that one? So that is nothing but here the dynamic memory allocation functions. So which are used for allocating the memory at runtime instead of compilation time in your program. So based on some input parameter, we are going to allocate. So in order to allocate this memory at runtime, we are provided certain library functions, dynamic memory allocation library functions in this stdlib.h header file. So what are those functions we are going to discuss now? So the first and foremost function is malloc, so which allocates the requested size of bytes and returns a pointer which is pointing to the first byte of the allocated space, and CALOC, which allocates the space for an array of elements, and that allocated memory is going to be initialized to 0, and it returns a pointer to the memory. And the third function is deallocation function, memory deallocation function. So this is what we are calling it as a free function, so which deallocates this previously allocated memory. After allocating the memory by making use of malloc or calloc, if you want to increase the size or decrease the size of the previously allocated memory, we can make use of realloc function. So which will change the previously allocated dynamic memory size. Either we can increase or decrease. So I think among these four functions, this free is called it as a deallocation function, and malloc, calloc, and realloc, they are comes under memory allocation functions. Now, if you see the malloc, which stands for memory allocation, and this function malloc reserves a block of memory of a space size, returns a pointer of type void type, which can be converted to a pointer of any form. So the syntax is of malloc is that some ptr is equal to, we have to typecast it, and then malloc of the size you have to specify that. For example, Here PTR is a pointer which we are converting into this cast type. So the MLOP function returns a pointer to an area of memory which is allocated of size byte size. So if the space is insufficient, allocation fails and returns null value to this pointer. So if malloc failed in allocating the requested amount of bytes, then it returns a null to this pointer. So PTR is equal to int star malloc of the size we are allocating here 100 into size of int. Suppose if an integer is occupying 2 bytes in your system, then 100 into 2, which is called it as a 200 bytes of memory, is going to be allocated. A one block of 200 bytes of memory is going to be allocated. If integer occupies 4 bytes, then 400 blocks of bytes of memory is going to be allocated. And it returns the address of the first block, which is allocated into this PTR. Then next, another function is calloc, which stands for contiguous allocation. So calloc stands for contiguous allocation of memory. The only difference between malloc and calloc is malloc allocates a single block of memory, whereas calloc allocates multiple blocks of memory, each of same size, and all that allocated memory is set to 0 values. Syntax of calloc is that again PTR is equal to cast type, data type casting, and calloc of n comma element size. So here it is taking 2 parameters, whereas malloc is taking only 1 parameter. So this statement will allocate contiguous space in memory for an array of n elements. So for example, PTR equal to float star calloc of 25 comma size of float. So we are allocating if for size of float is 4 bytes. So 4 bytes memory we are allocating contiguously of number 25 such 4 bytes memory blocks we are allocating. All these 4 bytes memory blocks are of size contiguous memory blocks of 25 we are allocating that. So it allocates 25 elements of each of 4 bytes. Fine. Then next, the third function is free, which is used for deallocating the memory which is allocated explicitly by making use of malloc or calloc. So free of pointer. So then it will remove that allocated memory. So it will free the space which is allocated by malloc or calloc and returns that pointer to the memory address. So this is a sample program which is used by making use of malloc function, how we can allocate the memory for the array and how we can do some of the elements entered into this array. So by making use of malloc, so and then number of elements, how many you want. So int star of malloc num into size of integer. So this is what the memory allocation is basically. So that is PTR stores the starting address. Fine. So by making use of PTR plus I, so which is enclosed within a for loop, we can read the elements and then we can calculate the sum, and that sum you can print it. So after that you can free that memory by making use of free of PTR. Fine. So this is an example program which makes use of malloc function. So the same program can be done by making use of calloc function. Only the difference is that in place of malloc, we are using the calloc function. So the difference here is that calloc is going to take 2 parameters. One is num, number of elements, comma, size of int. So the same code, except the calloc function calling, only it differs. Fine. So this is a remaining loop we are using here to read that elements, and then we are calculating the sum, and then we are printing it. After that you are freeing that memory. So this is what a realloc function. So this program demonstrates how we can reallocate the size of this memory based on that number of elements we want to give. So initially we assumed that n1 is the initial size of the array, and we are allocated the memory of n1 into size of integer by making use of malloc function, and then we are displaying that values. So after that, what we are doing, we are taking a new size and we are reallocating the memory. So realloc of PTR comma n2. So then that newly allocated memory, it is pointed by the pointer, and we are making use of that newly allocated memory. Fine. So this is how you can use that realloc function. Now coming to this reflections part, what are the differences between malloc and calloc? This is very important question in the dynamic memory allocation function. Generally, it is asked. Fine. So anyone can able to answer it. Malloc and calloc. Yes, if you are not able to answer this question, please refer to this. Watch this video from the beginning. So malloc stands for memory allocation. Calloc stands for contiguous allocation. Both these functions are defined in std_lib.h. And malloc will allocate a single block of the memory. Calloc allocate contiguous blocks of the same size. And malloc will take single argument and calloc will take two arguments. And the memory allocated using calloc, it will be initialized with zeros. Whereas the memory allocated with malloc, garbage values will be stored. Fine. So now lecture outcomes are revisited here. After completion of this session, students will able to make use of this DMA functions in writing of this program. So summary of the session is that in this particular session, we discussed about the different memory allocation functions, malloc, calloc, and then realloc. And dynamically allocated memory can be deallocated by making use of free function. Fine. So these are the three memory allocation functions, malloc, calloc, and realloc, and free is the deallocation. So this is about the lecture level practice problem. So I think this problem, write a program to find the average of n elements entered by the user. To perform this program, allocate the memory dynamically using calloc or ML. Fine. So these are the further references on this particular topic. So thank you, and for your patient listening.